Welcome to part 3. This is both going to be an introduction as well as a conclusion because I've finished running all the tests, and this is just me again talking a little bit about the hardware and talking about some of the conclusions I've come to and some of the pleasant surprises that I've had. One thing I wanted to mention: this cheap network adapter is a pile of crap. I mean, it works fine, but you're not gonna get more than about 5.5 megabits per second, whereas the Raspberry Pi will give you the promised 100 megabits per second in benchmarks. So bear that in mind. You might want to invest in something a little bit better than this cheapo that I'll post a link to. And I have tried plugging it directly into the USB without the USB adapter, and I've tried plugging it to the mini USB using the adapter that came with the MK802, but there's absolutely no difference in performance, and yeah, this is a pile of garbage, really. I mean, if you don't care about performance, fine, it's good value, but 100 megabits, give me a break. It doesn't even get 6. Let alone 10 or 20. I mean, you get 20, 30 on the wireless, and the wireless access point is downstairs somewhere. So you're better off using the wireless with power management disabled than getting this piece of shit. Okay, another thing I wanted to mention about hardware is I have a little USB bus-powered hard drive. This is a 2.5 inch. It has a spinning disc inside, and as you'd expect, if you plug it into the Raspberry Pi, let's see if anything at all happens. But I mean, you don't really expect a device like this to power this hard drive, do you? And it doesn't. Nothing happens. It doesn't spin up. It doesn't do anything. There's no LED, no nothing. Now you will be surprised if I do the exact same thing, plugging into here. There's a little USB adapter. So if I plug it on the side here. Oh, it's starting to spin up, and there should be an LED somewhere. Can't seem to see it right now, but the disk is actually spinning in my hand now. And if I SSH into the MK802, I can actually mount the hard drive and use it directly. So fantastic. I mean, this will require an additional power supply to power the hard drive, whereas this, if you're going to be using a 2.5 inch drive, seems to power it without any issues. So thumbs up. I mean, I'm quite impressed with that. So yeah, that's the hardware side. What I wanted to mention is the Raspberry Pi has improved significantly compared to maybe a month or two ago when I was testing, when I just received it and I've tested whatever was available at the time. There is a Debian repository, Raspbian. I'm probably not pronouncing that right, but Raspbian has optimized a lot of packages, and this is actually beating the MK802 in some tests, some of them quite significantly. It's still significantly slower at things like running typical Unix commands, running Ruby commands, compiling things, anything CPU intensive. But for instance, creating a Speaks audio file is significantly faster on the Raspberry Pi, so go figure. Anyway, I still would pick the MK802 overall, for the reasons I've mentioned in part 1 and 2, and it's still significantly faster in a lot of tests that I care about. I'm hoping the Raspberry Pi will catch up, and I'm hoping that the improvements in the Raspberry Pi will make their way to the MK802, and then it will be even faster. But without further ado, let's have a look at the benchmarks. For the first benchmark, I just wanted to check how fast both devices are writing to the SD card. So as we can see, I've run Bonnie++. I'm using 2000 megabytes because we need to do double the memory, so we have 1 gig on the MK802. Obviously we don't have nearly as much in the Raspberry Pi, but just to get a fair result, just to get a fair representation of how long the same test takes to run, I'm using the same exact parameters. We can see that the MK802 finished significantly quicker. So we can see close to 30 seconds quicker, or actually from about 30 seconds quicker. Also, the system time is significantly less, 3 times less. So we can see that roughly here. We have significantly less CPU use. If we have a look at all the figures here, we have 417 milliseconds at 40% CPU use. That's for sequential create. That's quite horrible compared to 443 US. So that's just generally the results are better on the MK802. The pure sequential block input is actually faster than I'm getting on the PC. On the PC, I can only get about 11 megabytes per second. Here we're getting 19. Here we're getting 20.5, so a little bit faster. But the figures are not that different for until you get to the kind of more CPU intensive stuff. We can see here 131 kilobytes per character sequential output with full CPU utilization, whereas here you're getting a mere 32. For the second test, I just wanted to check how fast the networking is. I've got a really cheap USB network adapter. I'll post the link in the video, and it's quite pathetic connecting to anything over the network. I can't seem to get more than about 5.5 megabits per second, whereas the Raspberry Pi gets 93. I can't really blame the MK802. I think it's mostly the fact that this is a really cheap USB adapter from eBay. I think it was $5 actually, so it was £3 or something, maybe £4 for delivery. But bear in mind that some of the tests I will mention that in future tests, but I mean they can be slightly in favor of the Raspberry Pi, but I will try to run the same tests both locally and over network to get a fair representation. Next test, I've actually got my FitPC2 in the mix, and the FitPC has let's have a look. So it has an Atom Z530 1.6 gigahertz. So it's not actually dual core. It has hyper-threading, but I've added it to the mix just to see what you get for your money, what you get in terms of performance compared to something like an Intel solution. And obviously here the FitPC is going to win. It's recording to an SSD rather than an SD card. But yeah, so this test isn't representative, but in future tests, when we are testing more CPU intensive tasks, it is going to set a good reference, because bear in mind the FitPC2 takes about 6 watts running, so off the plug. I have another video that I'll post a link to where I measure the power consumption of the FitPC. The Raspberry Pi and the MK802 take about 3.5 watts, so you're talking almost twice the power consumption on the FitPC. Nonetheless, let's see if it gets us at least twice the performance. Okay, for the third test, I've compiled X264 on the 3 machines, and we can see that the FitPC obviously wins, but it did take almost 4 minutes to compile, whereas the MK802 took 6.5, so not a huge difference, considering the FitPC is about 400 pounds and takes twice as much power, so it's not actually giving us twice as much speed here. Almost, not bad, but not quite. And the Raspberry Pi, it took 17 minutes, 10 seconds to compile X264. That's quite terrible. I mean, it's just so much slower than the MK802. Another thing is, when you try to run the executable, you can't actually run it, because I'm guessing X264 doesn't support the ARM v6 architecture either. So it seems everyone's moved on to v7, which is the latest right now. But v6 is definitely showing its age once again. There is an X264 that's coming off the Raspberry Pi repositories, so that's what I'll be using for the tests and in all of these. But yeah, it's quite disappointing because I can run it no problems with the MK802 and of course the Intel. FitPC2 has no problems either. For the next test, I wanted to see exactly what kind of performance we can get from video encoding. So I'm doing something which may look a little bit weird, but I'm taking an emotion JPG which was recorded off the camera. The video is almost like a static image. There's a bit of noise, but for the most part, it's a very easy image for x264 to compress, so we can get kind of a best case scenario result here. So I'm taking the image, I'm creating a pipe, and I'm piping it from my encoder, which will create a U4 MPG, which is supported by x264 for direct encoding. So since nothing's reading from the pipe, this is all stalled, waiting for me to run the next command. So the next command looks something like this. And I'm like I mentioned, I'm using the default x264 from the repositories. I will run another test using the compiled x264. But let's have a look what kind of results we're getting from all three. Okay, so here the intel is starting to show what it's made of. So we're getting 45 frames per second. That's not bad at all. You know, you certainly can look at maybe recording 2 cameras at the same time, or you know, doing video conferencing or anything like that. Bear in mind, we're using ultra fast and pretty low quality. CRF30 is significantly lower than, for instance, DVD quality, but nonetheless, it's quite a capable little CPU. The MK802 is only getting 17 frames per second, so realistically, you will not really get great results even from something like video conferencing if your camera is giving you motion JPG. So not great, but you know, compared to the Raspberry Pi, it's quite fantastic, because you know, 3.25 frames per second, which is, you know, I don't really need to comment on that, do I? Mention, if you're compiling x264 from source code on the MK802, you get about an extra frames per second. There's no significant difference on the FitPC2, and we can't test on the Raspberry Pi because of the illegal instruction. Also note, I've done another full run on both machines, and the Raspberry Pi is still chugging along through the original test, so very, very slow indeed. Here's an interesting test. If we try to encode a 60-second WAV file, which comprises of just pink noise, so quite challenging for the encoder. We see obviously the FitPC is going to win this one by quite a wide margin, but Raspberry Pi takes second place. So this package is coming from the Raspberry Pi repository as opposed to the Ubuntu repository. So it looks like they have done some optimization, because in the previous version, this was, you know, about a month ago, this figure used to be about 60-70 seconds compared to 15. So bear that in mind, that as long as people are willing to put in the time and effort, you probably can speed up a lot of these processes, and I'm sure that this can be optimized to beat the Raspberry Pi, considering this is a much faster CPU. One more test that demonstrates the Raspberry Pi actually destroying the MK802 in a benchmark for a change. So Speak's Enc is clearly been optimized in the Raspberry Pi repositories, whereas this again is using the default Ubuntu ones. So I'm hoping they will contribute the optimizations for V7, which benefits even more. And once again, the FitPC is the clear winner. I just wanted to say before I move on to the next benchmarks, well, it does look like the Raspberry Pi is beating the MK802 in a couple of benchmarks, probably because of various optimization and, you know, using the Raspbian distribution, which is a specific distribution of Debian for Raspberry Pi. You can have a look at the raspbian.org website for more details. But just generally, for instance, here I'm trying to install Rails. I've been waiting quite a while. I mean, this is almost neck and neck. This is a little bit ahead of installing documentation. But this has just started fetching the source, while this has already installed the entire stack and everything else. And just generally using the system, just running apt, running find, running top, running, you know, the standard Unix commands that you use day to day.
the Raspberry Pi is just quite painfully slow. You're sitting there just going, come on. Whereas the MK802 and the FitPC are just more pleasant to use, so better in mind.